Hey everyone, welcome. Today we're diving into a really cool new method that's teaching some of our most powerful AIs a very simple but really profound lesson, that to answer big questions about data, you first have to learn how to think smaller. It's a bit of a paradox, isn't it? We have these incredible large language models, LLMs, that can write poetry and debug code, but if you show them a massive spreadsheet and ask a pretty simple question, they can get completely lost. So what's going on here? Why does this happen?
All right, let's get right into it. The issue is what you might call AI's big table problem, and it's a fundamental challenge that really gets in the way of using AI to analyze all the huge amounts of structured data we have in the world.
At the very heart of this problem is something called a token limit. Honestly, the easiest way to think about it is like an AI's attention span. So if you try to feed it an entire massive table with, say, hundreds or even thousands of rows, you're just going to blow right past that limit. The AI literally can't see all the data at once. Yeah, this slide really just nails the gap between what we want and what we get. On the one hand, we expect the AI to just hit a bullseye every single time. But the reality, especially with a huge table, is totally different. Because of that token limit, the AI might only see a piece of the data, which naturally leads to errors. Or even worse, it might hallucinate. It just invents an answer that sounds right but is completely made up. But what if we completely flipped the approach? Instead of trying to force-feed the AI this giant table, what if we could help it focus on what's important? Well, that's exactly where this new method called TabSQLify comes into play. The researchers who created TabSQLify put it perfectly. They describe it as a way to break down or decompose these big tables into smaller, actually relevant subtables before you ask the AI to do the hard work of reasoning. It's a simple idea, but it's a brilliant shift in strategy. And this is the best analogy for it. The old way is like dumping a whole haystack in front of the AI and saying, hey, good luck finding that needle. But the TabSQLify approach is totally different. It uses a smart tool to pull out just the needle first, and then it hands that tiny, relevant piece to the AI for analysis. So much smarter. So, how does this whole thing actually work under the hood? Well, it all boils down to a really elegant two-step process. Okay, step one. The LLM does what it's already amazing at, understanding human language. It takes a normal question, one you or I would ask, and it translates it into a very precise database query language called SQL. Then, that SQL query goes and pulls out only the essential data, creating this tiny subtable. And only then, in step two, does the LLM actually have to think, reasoning over that small, focused piece of info to get the answer. Now, I know this might sound a little abstract, so let's walk through a real-world example straight from the research paper. You'll see just how effective this really is. So here's our question, and it's based on a big table of figure skating results from the Asian Winter Games. A simple, direct comparison. Who got more bronze medals, Japan or South Korea? So in step one, the LLM takes our question and translates it into this precise command right here. This is SQL. It's basically telling the database, hey, select the nation and bronze columns from the big table, but only where the nation is Japan or South Korea. It's a perfectly targeted request for just the data we need. And voila! Here's what we get back. Instead of a massive table with all the countries and every medal type, we get this, just 2 rows, 2 columns. All the other noise is just gone, leaving only the critical information we need to answer the question. Now, with this tiny little subtable, step 2 is a piece of cake for the LLM. It can easily see that 7 is bigger than 2 and generate a perfect logical answer. See? It wasn't overwhelmed, it wasn't confused, it was given exactly what it needed and nothing more. Okay, so that example is awesome. But does this actually work at scale? Well, the researchers put it through its paces on some seriously challenging datasets. And the results, they're pretty striking. This chart shows you just how massive the data reduction is. Take the WikiTQ dataset, for instance. That's that first bar there. TabSQLify absolutely slashed the average table size the AI had to look at, from 183 cells all the way down to just 32. That's what, an 82% reduction in all the noise it has to sift through? Incredible. And that size reduction pays off big time in performance. When you compare it to another advanced method, TabSQLify's accuracy jumped by over 12 percentage points on that WikiTQ dataset. So here's the crucial thing to remember. By focusing the AI on less data, it actually gets more answers right.
Now, take a look at this number, 0.0%. What on earth could that mean?
Well, that's the accuracy of a baseline AI model when you throw those really large tables at it, the ones that just completely shatter its token limit. It gets 0 answers correct. It just fails completely. But on those exact same tables, TabSQLify managed to get over 52% accuracy. This proves it doesn't just improve things, it makes answering questions on large tables possible in the first place. So, look, this is way more than just a clever technical trick. Let's wrap up by talking about why this whole filter-first approach really, truly matters for the future of AI. There are 4 huge benefits here. First, it scales up, letting AI handle massive data sets that would otherwise just break it. Second, it acts like a funnel, right? It filters out all of the irrelevant noise, making the AI's reasoning way more efficient and focused. Third, and this is a big one for trust, it's interpretable. We can actually look at the SQL query and see the AI's work to understand how it got its answer. And finally, you see that $sign? It says it all. By processing less data, it's more efficient and a whole lot cheaper to run. And that really brings us to a final thought. The core idea here is simple: teaching an AI to filter out the noise before it starts to reason. I mean, it's a strategy that we humans use all the time. So if this approach works this well for tables, where else could we apply it? If AI can learn to filter before it thinks, what other seemingly impossible problems can it solve next?